Alright guys, let's look at this problem also on Lasu PQ. Now, this problem says find the area enclosed between the curve y equals x cubed minus 4x squared plus 3x and the axis, that is, and the x-axis a pi, b 1, c 37/12, d 12/37. Now this is a kind of question under application of integration there, but this question is not a straightforward question. You know that in the previous videos I've dropped videos on getting area under a curve and using a case of definite integration where they will give us boundary when they say x equals 1 and x equals 2. But this case here, they did not give us any boundary. Now there is a lot to this question, but because it's a CBT exam, I will be doing it in a way that will not, bore us a lot. So now let's get to solve this question here. Now, since we are not giving our boundary, we are the one that will get the boundary ourselves. So now, how do we get our boundary? Now, when you want to get your boundary will also be the x-intercept. When we mean the x-intercept, it means the point at which this curve cuts the x-axis. That's how you will get your boundary. Then once we have our boundary, we now get the area enclosed between this curve here and the x-axis. The graph will be something of this nature. When we have something of this nature, so we want to get this point, and this point. So that's how we will now get our boundary. This point will be 0, this point we don't know, this point we know. So what we will use this equation here to get the roots. Once we get the root of the equation, then we will fix it in this graph. But because it's a CBT exam, we don't really need to draw graph. Now next up, when we have this man here, y equals x cubed minus 4x squared plus 3x there. Now from here, the next thing is to equate this man here to 0 so as to get the roots, right? X cubed minus 4x squared plus 3x equals 0, right? So now, if we are to factorize this man here so that we can get the root, let's say, okay, x is common in everything. Let's also factorize x out. Then we'll be having x squared minus, this one will be what? 4x plus 3 equals 0 there. Now from here, we can factorize this man here. If we factorize this man here, we'll be having x minus 1, then x minus 3 there. That's what we'll be having if you factorize this man here. Now from here, we can get the roots. We just equate each of these terms to 0. Now if we equate x to 0, it will still be x equals 0 there. And if we equate x minus 1 to 0, we'll be having what? X equals 1. And if we equate x minus 3 to 0, that is x equals 1 in the sense that the minus 1 will come to this side to the right hand side, hence making it 1, not minus 1 again. Now x minus 3 equating it to 0, the minus 3 will come to the other side, hence we'll be having what? X equals 3. So these are the 3 roots, and these are what we will use to get the boundary, or these are the boundary. Now it's very simple here, because the curves look like this. So this is one area and this is another area. So they are trying to, let's say this one is area 1 and this one is area 2. I'm just using this for like visual explanation. So this one is area 1, this one is area 2. So the total area enclosed between this curve here and the x-axis will be the total area, let's say AT, will be equal to A1 plus A2. Now it's not just equal to A1 plus A2, it will be equal to the absolute value. because we won't, if whenever we have negative, we have to take the absolute value. That if you have minus 2 over 5, you'll be equating it to what? 2 over 5. And the case is that whenever you see something coming down this x-axis that is below x-axis, we will always have negative because it is below the x-axis. Hence we have to take the absolute. So this is what we are using here. Now to get this is our to get our boundary is just very common. The boundaries will be what? First thing first, we can't say 0 to 3. So the boundary will be, if this is 0 here and this is 1, so the boundary between this point is 0 to 1. So the first boundary will be 0, 1, and the second boundary will be what? From 1 here to, from 1 to 3. So that's 1 and 3. So this is the two stuff we have here. So this is for the area 1 and this is for the area and this is for the area 1 and this is for the area 2, right? Now next up, we just have to, the next thing in a multiple choice when you see this kind of question, because this is a past question, is to integrate this man. You know, under our concept of finding area, we always integrate the equation, but the problem here is that we did not give us boundary, but now we've gotten our boundary. So let us integrate this man here and work with this. So when we integrate this man here, we have x cubed minus 4x squared plus 3x. If we integrate this man here, we'll be having something of x raised to power 4. Just integrate each term independently, add 1, then divide by the result. So divide by 4 because it's 4 that is here, minus, now if you have 4x, add 1 to the power 3, then divide by the 3, right? So next up will be what? Plus 3x2, because it's already 1 that is here, then you just add 1 and divide by the 2, which is this power. So this is the integral here of this man here. So the next thing is to get our a1 and a2. How do we get our a1? Using the boundary. Now let's say for the a1, so we have this man here, we just have to say, now for the a1 it will be what? X raised to power 4 over what there? 4. X raised to power 4 over 4 minus 4x cubed over 3 plus 3x squared over 2. Then we say from, as it stands from 0 to 1, because this area 1 is coming from 0 to 1. So from here, and you know what we do, we subtract, we impute the upper boundary first and we do our lower boundary, then we subtract the lower boundary from the upper boundary. But okay, let's move on. But the key concept here, because it's a multiple choice question, if you input 0 here when you are doing for the lower boundary, you know that it will surely give you 0, because 0 here, everything will be giving you 0. And let's just do for the upper boundary. So let's just look for the upper boundary. So if you punch everything in and you just impute the 1 here, let's look at what we will get. So it will be what? X, no, let's say so we'll be having, in place of x we are putting 1 there, so that's raised to power 4. So that's raised to power 4, right? And if you check out the, so divided by 4, right? So we won't waste time. So minus, we have another this thing here, then we say 4, then in place of x we put 1 cube here, then all divided by, what do we have there? 3, then plus, right? We have another thing, 3, then in place of x we put what there? We put 1 there. That will be raised to the power of 2, then all divided by 2. So that's all. So we are getting our for the upper boundary as 5 over 2. So the result is 5/2. So we don't really need to do for the lower boundary. It's just a logical stuff there, because 0, if you input 0 in everything, it will surely give us 0. Now let's look for the A2. So the A1 is 5/2. Don't forget that we are still going to add it to the A2. That's why we are looking for the A2. So the A2, now it's already plus. No need of saying we are taking the absolute, because it's already plus. So now for the A2, we just have to say x raised to power 4/4 minus 4x cubed over 3 plus 3x squared over 2, right? Plus 3x over 2, as it tends from what? 1 to 3. As it tends from 1 to 3, right? So from here now, we can basically get for the upper boundary and the lower boundary. Hence, we subtract the lower boundary from the upper boundary. So let's do that using the calculator. Now, in place of, let's get for the upper boundary pause. In place of x, we put 3. So that's 3 raised to power 4 divided by 4 minus 4, then 3 raised to power 3 there, divided by 3, right? Plus, we have another stuff there, this one here, 3. In place of x, we put 3. So that's 3 raised to power 2 all divided by 2, right? So what's the answer? So our answer here is 9/4, right? 9/4 there. So that's 9/4 for this upper boundary. So no, it's the answer here is minus 9/4. So it's minus 9/4. So now the next thing is to subtract. That's minus. Let's look for the lower boundary. In place of x, we put 1. So it is in place of x, we put 1. So actually, we've actually substituted 1 in place of x before, and we got our answer as 5/2. So if we punch it again, it will still be 5/2, not to waste time. So now if we do this man here, let's solve this man here. Minus 9/4 minus 5/2. So that will be minus 9 over minus 9/4 minus 5/12. So that's simply minus 8/3. Is that simply what? Minus 8/3. Because if you see it here, it is what? Minus 8/3. So the next thing we have to do here is to take the absolute value. So the result will be 8/3. That's our A2. Hence, A1 is what there? 5/2. Or 5/12. And that's absolute A1. Absolute A2 is what? 8/3. That means the area here is 5/12, and the area here, the reason why this A2 is giving us negative is because it is below the x-axis. Hence we took the absolute, and the area here is 8/3. Hence the total area there, it will be what? A1 plus A2, right? And that's 5/12 plus what? 8/3. And if we punch this in the calculator, that's 5/12 plus 8/3. And the correct answer here, in the calculator here, is that's 37. And the correct answer here is what? 37/12. Can see how this question is kind of tricky. So the correct answer here is 37/12, making option C the correct answer. So that's how to go about this kind of question if you see it in exam first thing first, and they did not give you boundary, you have to get your boundary, factorize this one, you get the roots, then you take the roots from year to year, from the smallest to, when you have three roots, you take it like that. Then after that, you integrate this one here, you check in for your first root, like the first set of roots will be the one you use to get your A1, and the second set of roots will be the one to get your A2, that is area enclosed, the second area enclosed by the curve. So this diagram is just for better understanding. So that's how to go about this particular problem. Watch out for more videos.